All right, so I think I'm recording. Let's take a look at this problem number 5. We want to answer these things about this function. These trigonometric functions are periodic. The period is the length, and it's the length on the x-axis that it takes to complete one cycle. Then that cycle continues for the sine and cosine forever to the left and right, so the domain is all real numbers. To find the period, you always take 2 pi divided by the coefficient in front of x. And we see that the 2's will cancel, and to divide by 1/7 is the same as to multiply by 7. So this is a horizontal stretch, and this period is 7 pi. The amplitude, and remember, since it's a distance, it's positive. This -6, the multiplier out in front, you take the absolute value, and the amplitude is 6. The center line is the vertical shift that you're taking the output of the function, and are you lifting it up or pushing it down? Since this is plus 0, my center line, and it is a line, a horizontal line, and it's y equals 0. Now, with this change in the period and subtracting this is a shift to the right. It's going to affect where the normal parent curve intersects the center line. I know that the normal sine curve intersects its center line in this first primary cycle here at the origin, here at x equals 0. So if I were taking the sine of 0, then I would be at my center line, because the sine of 0 is 0, and my center line is y equals 0. So what I do is I replace this 2/7 x minus 2 pi over 3. If I can replace that with 0, then I know I'll be at the center line. So let's determine the x that satisfies this equation that will make, if you input that value, it will make that expression equal to 0. So let's solve this for x. We've got 2/7 x is equal to 2 pi over 3. The 2's cancel, and let's multiply by 7, and I've got 7 pi over 3. So I know that if we plug in 7 pi over 3, we're going to get 0 in the sine of 0, 0. Now I also know that these points are equally spaced, and that I'll cross the center line again at a distance away from this x value at half the period. So half of 7 pi divided by 2, and n is just an integer, 0 plus or minus 1 plus or minus 2 plus or minus 3, just telling you how many jumps of 7 pi over 2 you're doing on the x-axis to get to that next point on the center line. All right, with the center line at 0 and an amplitude of 6, our maximum value is 6 units above 0, so it's 0 plus 6. 6 units below 0, well, that's a -6. And we know that the sine curve is maximum when you're taking the sine of pi over 2, because its maximum value is 1. So if I can figure out the x value to plug in so that this expression will be pi over 2, I know that I'll be at a maximum value. So let's solve this for x. If we have 2/7 x is equal to, if we have pi over 2 and adding 2 pi over 3, we want a common denominator of 6. So I'm going to multiply that by 3, and I'm going to multiply this by 2 over 2. So I'm adding 2 times 2 is 4. So this 2/7 x is equal to 7 pi over 6. Multiply by the reciprocal of 2/7, multiply both sides by 7 over 2, and the 2's and 7's cancel here, and I just have x, and I've got to multiply this by 7 over 2. And that's a terrible looking 2. 7 times 7 is 49, don't forget the pi, and 6 times 2 is 12. So I know that if I input 49 pi over 12, and that if I know that the maximum values and also the minimum values are a period apart from each other. So the length of the period is 7 pi, so I'm adding 7 pi in. All right, now for the minimum value, we're at 3 pi over 2. The sine of 3 pi over 2 is -1. So if we determine the x, that if we plug it into this function, that if we're taking the sine of 3 pi over 2, then we'll be at a negative. So we want this expression to equal 3 pi over 2 and solve for x. All right, so this 2/7 x, and again, let's get a common denominator of 6. So I've got 9 pi over 6. If I multiply that by 3 over 3, and now multiply this by 2 over 2, and I'm adding 4 pi over 6. So I know this 2/7 x is 13 pi over 6. And if I multiply by the reciprocal here, I get x on this side. So I have to multiply this side by 7 over 2. 6 times 2 is 12. And 13 times 7, is that 91? 7 times 3 is 21. Carry the 2, 7, yeah. All right, so this is 91 pi over 12. And the next time it'll be at its minimum is in the next cycle, and that's, for this problem, 7 pi away. So I'm going to add or subtract multiples of 7 pi to be at a minimum value. So there's our answer for number 5. Let's take a look at this next one. Now this time they give it to us in factored form, but we know that the period is 2 pi divided by the coefficient in front of x. So right now you might mistakenly think that's 1, but remember you've got to distribute this pi over 15 through there. So to divide by pi over 15 is to multiply by 15 over pi. The pi's cancel, and 2 times 15, boy, that's a length, that's a period of 30. This is truly a horizontal stretch. The amplitude is the number that's in front here. Now remember that since both of these are distances, these are going to be positive numbers. The center line is the vertical shift, and in this case we have shifted this graph down 5.9 units. So not 0.5. My center line is negative 5.9. All right, with an amplitude of 9, the maximum value I know is 9 units above that. I don't want to make a silly error on a Friday afternoon, so I'm not embarrassed to check things on my calculator because I know that mental arithmetic, 3.1. So that's the maximum value, because if we're 9 units above this, we're at a max. If we're 9 units below it, if we change this to subtraction, my minimum value is down here at negative 14.90. All right, so let's come in and for the sine curve, we know we're at our center line at 0. So let's sketch the sine. It goes up and then like this. And so this is my center line. At 0, I'm at my center line. So if this pi over 15 times x minus 24, if that's equal to 0, I know I'll be at my center line. Well, that means that 24 minus 24 is 0. I can see by inspection that x is 24. So at x equals 24, if you plug in 24, 24 minus 24 is 0. Pi over 15 times 0 is 0, and the sine of 0 is 0. And we'll be at this, the output, negative 5.9, will be at this center line. Now, our center lines are equally spaced, and they're half a unit apart, or half a cycle apart. It's a half a period. So if the period is 30, then I know that if I add or subtract 15, I'll be at the next center line. And in fact, not just 15, but multiples of 15, then I'll be at the center line. So this is describing infinitely many times that this graph intersects its center line. Now, if to be at a maximum value for sine, we know that happens at the first time here at pi over 2. And if this expression were allowed to simplify and equal pi over 2, we know we'd be at a max because the sine of pi over 2 is 1, and we would have 9 minus 5.9, yeah, over here at the min it'd be a negative minus a negative. So yeah, okay, it's still good. Let's divide both sides by pi. Let's multiply both sides by 15. X minus 24. Uh, I'm listening to Bob and Tom. You can't hear it, but I'm listening to Bob and Tom show, and it's making me laugh. It's distracting me. I probably should turn it off here. Get a denominator of 2, and I've got 15 plus 48. 15 plus 48, and that's a 63 over 2. So if I input 63 over 2, then I claim that that's going to be a 1. I'm going to be at a max, and I know that the next max is a whole cycle away, and if the cycle is 30, then if you add or subtract multiples of 30, you'll be at the next maximum. All right, so to figure out the minimum value, instead of pi over 2, we're at a minimum on sine at 3 pi over 2. So the sine of 3 pi over 2 will be its minimum value. Let's figure out what x will cause this algebraic expression to be 3 pi over 2. The pi's cancel. If we multiply by 15, we've got x minus 24. 3 times 15 hopefully is 45. And if I get a common denominator of 2, I've got 45 plus 48. And that looks to be 93 over 2. So if we substitute in 93 over 2 for x, then I claim that this is going to be 3 pi over 2. Then the sine of 3 pi over 2 is negative 1, and you'll have negative 9 minus 5.9, which is negative 14. You'll be at a minimum. And if you're a cycle away, if you're a period away from this, plus 30 in, you'll be at this minimum value. For values of n that are 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on, you input that into this function, and the output of this function is going to be this minimum value. All right, so I hope that helps. I'll talk to you later.